Welcome to Fertility Village. This is your weekly live talk show where community and support come together. With rotating hosts, expert guests, and meaningful conversations, we're here to guide you through the highs and the lows of infertility. Whether you're searching for answers, seeking advice, or just looking for a special place to belong, Fertility Village is your space to connect, learn, and grow. Because it really does take a village, and we are here for you every step of the way. Thanks for joining. Hello, everybody. Welcome to Fertility Village Live. Sorry, Tanya. Cut you off. We're live.
Okay. We are mostly live. It's telling me that we're having some trouble with our Instagram, but I'm trying to fix it as we speak.
Okay, we're working on fixing Instagram. You know Tanya, you know me. I'm Erin. We're hosting tonight Fertility Village Live. Welcome everybody who's tuning in from YouTube and Facebook at the moment. Tonight, we're so glad that you're joining us today for this fascinating and incredibly important conversation. We are celebrating this month Men's Health Awareness Month in June. And so we have a really important conversation about male fertility tonight. I know we are often focused on women's health on this podcast with regards to infertility, but it's often men who really suffer in silence. So we want to start to expose some of the things that men are suffering through with male factor infertility. So tonight we are welcoming a leading expert in the field, Dr. Mathieu, I'm going to botch this, Boilard. Please pronounce it for us. I'm not French. I don't pretend to be French. I say a lot of swear words. That's sometimes considered French. But Mathieu is the founder of Nasci Biomed, and we met last year in Vancouver at the CFAS conference. And I honestly, like in 10 minutes talking to Dr. Matt, I learned so much about male factor that I didn't know, which is part of sort of my diagnosis with me and my partner. And so I was fascinated by by just everything, the research that you're doing and what you're learning. So we are so excited to welcome you here tonight. Absolutely cutting edge research and diagnostic labs based in Quebec, Canada. So I'm going to let you tell us a little bit about yourself. Welcome to the show, and tell us a little bit about yourself and what does Nasci Biomed do at the moment.
Thank you for the introduction, Erin. And yeah, that is correct. We met at the CFAS meeting in Vancouver last year, and I was very pleased to meet you. Very pleased to know about the existence of your organization and all the efforts you're putting forward to get some information, get some explanations to people about, what's available out there, what people can do for them. I think it's great. My name is Mathieu Boilard, and my wife, Lynn, is co-founder of a company called Nasci Biomed. And to begin with, we're two researchers in the field of physiology or reproduction, right? So you can see us as lab rats. Okay, we're not physicians by any means. I don't have medical training whatsoever. Okay, so my career is being a researcher in cell biology. So what I understand deeply is the chemistry that happens within cells. I understand, how DNA is copied into RNA and how RNA is converted into useful proteins that will act within your cells. I understand cell-to-cell interactions. I understand why cells divide, why they won't divide, why they will die, what they eat, what they don't like to eat, what affects them, these type of things. But I'm also a biologist, and as a biologist, what I like to study is how reproduction works. So physicians are more focused on, let's say, the lifespan of an individual. Well, biologists are more interested about how they reproduce by definition. So that's basically what led me to being more and more interested into understanding how reproduction works. So my wife, Lynn, who co-founded the company, is actually a biochemist by formation. So she underwent the same courses as I when she was a graduate student. We both PhD in physiology of reproduction, meaning that we were handling a lot of sperm cells, a lot of oocytes, a lot of embryos in the lab, mostly from animal species to get good at it, and also conduct research projects that we could not conduct on human beings for lack of materials or biological materials, or from lack of from ethical considerations, to be honest with you. You can do a lot of things with gametes in animals that you can't do with human gametes. So she was trained as a PhD in embryology, just like I was trained in sperm cell biology as a PhD. And then she went on and did we call it a postdoctoral degree at University of Montreal in clinical chemistry. So she's a clinical chemist. What it means is that she is one of the probably roughly like 200 experts in Canada who are able to go from a lab experiment and bring it to a clinical test. So the expertise that she has is transfer of technology from a research lab to making it a clinical test. So whatever I tried to develop as a new test using flow cytometry on sperm cells, she'll come to me and say, look, all your stuff is great, but we need to measure how good it is for real, and document that mathematically and make sure that it becomes a clinical test that we can sell to physicians and patients. So there's a big difference between just, knocking it off in the lab and producing a medical test. So the bridge between the two is the expertise of a clinical chemist. So we founded this company. It was in 2011, first patients in 2012. And what we do is we develop new sperm tests, new ways of measuring if sperm are fertile or not. And we try to provide it to patients.
Amazing. What I got from all of that was you guys are really, really super smart, superhumans who are fixing male factor fertility, and you're doing it with new testing. And wow, I'm always blown away in chatting with you. You have so much amazing information to share with us. So you're involved in some ongoing research. Can you talk about how Nasci is working on developing new technologies that might lead to major breakthroughs in male fertility?
Yeah, I can give you some examples over the past couple of years. Well, one thing that has always been surprising to me since the beginning of, IVF is that, I was probably at high school when IVF was invented. It started to be applied. But rapidly, I started my training in science at the beginning of the 90s, and then became a biologist in the 90s and started my graduate studies in the late 90s. And after that, I've always been in this field. But what struck me is that there's been a lot of, a lot of new discoveries on how sperm cells work over the course of the 80s, the 90s, the 2000s, et cetera. And just a little of that knowledge has been translated to, real clinical applications. It seems like, the routine evaluation of sperm on the male side has been, basically the same for many, many, many decades, whereas the knowledge of, how a sperm cell works has been rocketing, to be honest. So the gap between what researchers know and what is applied in the clinical field is just increasing all the time. Just to give you an example of what we do, over the past couple of years, we've developed a new way of detecting rare sperm cells in human samples that's led us to develop a new test for post-vasectomy checks, vasectomy reversal checks, azoospermia investigations. We've been developing a new test to rapidly and very efficiently quantify the amount of leukocytes in sperm cells. We've been developing a new test, or I should say, improving an older version of the reference test for DNA fragmentation. We developed new ways of measuring the integrity of mitochondria, acrosomal vesicles in sperm cells. So we include that into our analysis. So these analyses that we offer are getting more and more robust, more and more precise, more and more useful, we hope. So this is the type of work that we try to do. Bring the science that exists from others' work, from academic work, to on the plate of patients who might be needing it.
There's so much that you just said there. I'm just still trying to process. Give me a second. So you have some core services, obviously, that you offer. Tell us about the fertility spermogram. Other than having a really cool name, what is it? How does it work? How can it help?
Yeah, the fertility spermogram, in fact, is an analysis that you absolutely need to get done as soon as you have symptoms of of fertility problems. What is fertility problems? Well, in Canada and in the U.S. at least, but it's mainly across Western civilization and even elsewhere. The subfertility is defined as if you've been trying to conceive for at least a year without success. Usually, we will doctors would want to intervene after 6 months if one of the members of the couple has 35 years old, sorry. Just to give them time to act on the problem, as the women and the men are both aging, and success rates for potential treatments might drop faster. But so if you're in this window of 6 months to 12 months of unsuccessful conception, well, it's time to do a spermogram. And what this analysis does, the real basic stuff that you need to measure in order to be producing what doctors minimally expect is concentration measurement. So how many sperm cells have been ejaculated, how many there is per ml, per milliliter of seminal plasma. You need to measure what's the percentage of cells that's motile, and you need to have a morphology score done. We call it the Kruger criteria, so we call it strict morphology nowadays. So these are the three principal things that the spermogram will verify. So
the spermogram is like baseline male fertility testing.
Yeah, like every hospital in the US and Canada probably do it all the time, in Europe as well.
Yeah.
It's just, is there something major that, that can't be missed, that we can identify rapidly, that would explain everything, like absence of spermatozoa in the sample, or complete azoospermia, like there's not a single sperm cell moving. These type of things, the standard routine microscopy spermogram will probably catch, right? So that's what happens. So physically, what happens is just that, a sperm sample gets delivered, and there's a technologist in the lab that pipettes a small sample of the whole thing, puts it on a microscope slide, and observe it under the microscope, so they can have a look at what's going on. It's an estimation, right? You can use computer-assisted system to film what's going on the microscope and have a software help you with the analysis. Yep. But it remains like estimations, because you don't measure that many sperm cells. When you look at that, you might run an analysis maybe on 100, 500, maybe 1,000 sperm cells, but rarely. So it's just a glimpse of what's going on there. You have a look at what's going on, basically.
Yeah. So interesting. And I mean, correct me if I'm wrong, but just in my experiences with our support groups and talking to other people and doctors over the last few years, there's been a massive decline of like what's normal sperm count. So whereas even a decade or 2 decades ago, normal was like X amount of millions per milliliter. And now it's much lower, but that's still like normal. So, do you have anything to say about that? Like, is there a specific anything? I mean, people ask us all the time, like, oh, why is fertility declining? I get that question a lot. Well, why is it not declining? So many things are contributing to the reasons for, infertility in general. So would it be the same for sperm, or do you think there's something that's majorly contributing to this generation and the decline of sperm?
Yeah, well, there are many things to explain in what you just said. The first thing is that sometimes, as biologists, we will consider fertility as how many children are born per couple. Okay, so that decline has more there's more involved than just sperm quality in that, right? There's life choices, for instance, right? If people just choose to have less children, it's going to be reported as a decline in fertility in some reports. It's actually not a physiological fertility problem. It's just that people conceive less children, but it's out of their will, right? So that's one thing. For the side of what's happening physiologically, there's been an accumulation of reports showing that the total number of sperm cells ejaculated by a man over the last few decades has been declining. Lots of things might be involved in that. One of them is, well, the first thing people are pointing out all the time, because it worries them, is the quality of the environment, right? You could have like endocrine disruptors, pollution, BPCs and stuff like that, accumulating in your body, influencing how spermatogenesis is happening in a man's body, et cetera, et cetera. But there are also many other factors that people don't like to admit might be involved. In order for your body working well, people have to stay in shape, right? And physiology of reproduction in men is super linked to, how well the guy can rest, how well the guy can, be active, stay in his normal BMI 20-25, what he eats, is his diet over in calories and stuff like that. So those things we can control. And I'm pretty sure that one of the big factors, the two big factors I think are creating fertility problems in society right now is the fact that people tend to have their children later in life, which is a choice, and also the fact that obesity is like rocketing in North America these days, and so these two factors are big. They have a pretty big impact, and they have an impact beyond what people think. Obesity can have an impact on how gene expression is passed on in the next generation. So the accumulation of these causes might lead to lower sperm counts and fertility problems down the line. But I don't know for a fact that the decline in the number of sperm cells has reduced the number of women that are pregnant after a year of attempting having a child. So if you compare a species, we're not artiodactyls, we're not mooses, we're not deers, we're not we're not bovine. In the moose, just to give you an example, female accept to be copulated only once in a year, and after a year, because the male are so big compared to them, they risk basically dying every time. So what happens is after a year, roughly 90% of the female are pregnant. But the fact that the copulation happens only once in a year, it puts an incredible pressure on sperm quality to deliver the genetic material, right? Of course. Whereas in humans, like in humanoid primates, like the gorillas, the bonobos, the chimps, and the human, copulation happens all the time. So it's just a very different way of reproducing, which puts less pressure on sperm quality. And we might not be in such a big position in terms of fertility per se. Of course, if you look at a sperm sample in a human and you compare it to a horse sample, or a pig sample or a rat sample, the sperm quality is very, very different. But we're primates. We don't breed only once a year. That's what happens, right?
Wow, that's just so interesting. So going back to the spermogram and just the baseline fertility testing, it's my understanding that Nasci Biomed offers beyond what most hospitals and clinics provide. So could you speak to that a little bit?
Yeah. So as I was explaining earlier when we started, the work that's being done by hospitals and by fertility clinics is a super good job. It has to be done. It's just that it kind of stagnated a few decades back to a level that we need to go beyond nowadays. It's 2026 tomorrow morning. We're not in 1992 anymore. And a lot of the things that we do is very similar to 1992. Measuring sperm cells in a spermogram is necessary. You need to check if there are sperm cells there. You need to check if they're motile. You need to have a look at their shape, their morphology. There's a lot of information you can pick up from there. But if you stop there, and consider that the male is fertile, just based on the fact that the parameters of the very simple spermogram that's always been done are normal, well, you're going to create some problems down the line, because we've known since the 1950s that sperm cells need to mature in order to become able to fertilize an oocyte. All right, the papers have been published in 1951, 52, right? So that sperm mature in the female genital tract, and they undergo some sort of chemical transformation so that they can become able to fertilize an oocyte. And this is related. Nowadays, we know what happens, right? We know how sperm, well, we know better. We don't understand it fully, but we know much better of what's the type of transformation that the sperm undergoes between ejaculation and the moment it fertilizes an oocyte. And these processes are important. If there's a problem there, it can create a big problem of fertility for a couple. And so there are ways nowadays that we can measure these things, and it has to be measured if you want to help a couple conceive, because if you don't measure them and you send them randomly into the treatments, well, some of the treatments have basically no chance of success. So at some point, if you don't check it, couples are going to be submitted to treatments that have no chance of success, and they're just going to lose their money, their time, and their energy, quite frankly. They get discouraged, and for good reasons. So our philosophy at Nasci has always been to try to, get as many data as possible on the male side, so the decisions downwards are made with as much logic as possible. So just to give you an example, the simple fact of measuring concentration more precisely helps. Why is that? Well, if you have a man that shows up and he's oligospermic, meaning that the sperm numbers are quite low, and the doctor chooses to make a small change in his way of life, let's say improve sleep, quit on the drugs, stop alcohol, whatever, and there's an improvement of 5 to 10%. Well, if you're just estimating using a microscope what the concentration are, that 5 to 10% variation gets lost into the methodological errors of the lab. So if you produce two sperm samples, if you submit the same sperm sample twice to the lab, and you're using not super sophisticated techniques, you can create a 5 to 10% variation between the two readings of the same sample. So how do you discriminate after that between a sample that's been produced at time 0 and then time 10, let's say, 10 weeks later, with a huge improvement in the way of life? If there's been an improvement of 10% in this guy's semen, and the methodological error of your lab is 10%, you're not going to be able statistically to identify the improvement. So we're just working on basic stuff like that, so that people can make sense out of the results and take the right decisions. But yeah, there's a lot of stuff that we're trying to improve the measurement of, a lot of parameters that are just left unchecked by the routine analysis, and couples sent to treatments, whereas they should be not attempting a certain type of treatment, or fast forwarded to more heavy treatments sometimes. So yeah, a lot to be done.
Yeah, so it sounds like there's a lot of things that can go into male infertility, but what are some of the common diagnoses that someone might receive from a sperm analysis?
Yeah, common diagnostics are related to sperm quantity, motility, morphology, stuff like that. So you'll see if you read several reports of semen analysis, for instance, or if you read on forums, or if you listen to experts talking about it on YouTube or whatever, they're going to talk about, let's say, oligospermia, right? Oligospermia means that there's not a lot of sperm cells being ejaculated in the sample, okay? So oligo means few, basically. You're going to see the word astenosospermia. So astenos is a Greek word, if memory serves, that means lazy. So if you talk about azoospermia, what it means is that there's a low percentage of spermatozoa that are actually moving, that are motile. Okay. Teratospermia refers to bad morphology. Sometimes we have men that we barely can find a single sperm cell that has what we would call a normal shape. We have to observe it at about 1000x on the microscope. We usually run an analysis where we look at roughly 200 sperm cells, sometimes more, but most of the time 200s. And if you can't find a sperm cell that's well shapen out of 200, or just a few of them, like less than 4% will be called teratospermia. But there are also other fancy words like oligospermia would mean that there's a lot of leukocytes, white blood cells in the semen sample. It's normal to have white blood cells in your semen, but too much of them can indicate infections or at least an inflammation inside the genitalia of the male. So that's a word we use, leucospermia. We can talk about cryptozoospermia. That's like almost no spermatozoa, like less than 100,000 per ml. You'll see words like hypospermia. Hypospermia would mean low volume of ejaculate. Hyperspermia we see sometimes, like too much volume in the ejaculate, which might indicate that there's not only sperm in the sample that's been provided, but lymph might be present. So we would probably find leucospermia at the same time because lymph contains a lot of white blood cells. So all these things are possible and are very common. We often see men with oligoastenotteratospermia. They are called OAT, O-A-T. So the OAT means oligoastenotteratospermia. So there are sperm cells in there, but not a lot. They don't move much, and their morphology is not as good as we would like.
Oh, you're muted, Tanya.
Oh yeah, Tanya, I couldn't hear you.
That's
there.
okay. We're live.
Earlier.
That's okay. All good.
So in our support groups, we have a lot of conversations that land on DNA fragmentation.
Mm-hmm.
What is it? Tell us about it.
Yeah, DNA fragmentation is more about measuring what's inside the truck, I call it, right?
Yeah.
So when you do a spermogram, what you do is you check if the engine starts, if you can, put the truck into gear, first gear, unclutch, get the wheels rolling. How fast can we drive? And is the engine cooling well? Do we have current? Can we start the heating? Stuff like that. That's all about how the vehicle works. That's the spermogram part. That's the sperm physiology part. But in fact, nobody really cares about the sperm cell itself, right? What matters is this little thing is supposed to carry genetic material from the paternal side to the oocyte, so the oocyte can do its magic and convert its own genetics, mix it with the male genetics, and create a new genetic that's never been existing before and create a baby out of it. So what matters is the DNA inside the sperm cell, the genetic code of the father. So the role of the sperm cell is to carry that to the oocyte. So the problem that we have is sometimes, because a sperm cell is basically a very light truck, right? It gets rid of all the apparatus that would be needed to repair DNA. So DNA gets broken all the time in a living cell, right? But there are mechanisms to repair it, enzymes that are at work all the time. As I'm breathing, as you're breathing right now, you're somewhere, everywhere in your body, your cells are repairing your own DNA, or at least protecting it. But sperm cells get rid of that. They don't have the machinery to repair the DNA once they are fabricated. So they're left at themselves. They can't correct any problem that will happen between the moment they've been created by spermatogenesis in the testes all the way to the oocyte. So we want to check, what's in the trunk of the truck. Is it still in shape? And that's really what we're trying to do here. The load of the truck, the DNA has to be in good shape to create a good baby. So when we do DNA fragmentation testing, what we're measuring really is, how bad the DNA has nicks in it. we call it nicks, like single or double strand breaks, okay, in the chain. DNA is a molecule, so a lot of atoms connected to one another, and it forms kind of a spiral shaped molecule. You've seen it, on television, on YouTube. Every time people talk about DNA, they explain the structure of it. So sometimes the chain can break in some parts, but the problem is that the gene is a sequence of parts of the DNA. So if there's a break somewhere in a gene, it's not a good idea, because if you break in the middle of a gene, you're never going to be able to synthesize a protein out of that gene down the line. So too many of these nicks, too many of these breaks in the DNA can indicate, problems during the spermatogenesis process, or too much stress, for instance, oxidative stress on sperm cells. It can indicate also why couples have repeated pregnancy loss. So we need to check the parameters sooner than later, because men who have DNA fragmentation problems, their chances of natural conception are very low, up to 7 times less, and their chances in IUI are just as bad. So the best case scenario is when you see a couple, you want to test for this parameter even before IUI is attempted. So you can decide if you're going to insist on IUI or, bring them to IVF faster than later.
Yeah, this is one of like the questions we get so much in our support groups, and I've seen women learn and couples learn about this. What is DNA fragmentation? And then go and ask their doctor for it when they've been doing 2 or 3 or 4 IUIs already, because that's just the natural first step at a fertility clinic. In most cases, bit of a money grab there as well, right? And also it's like, let's rule out the micro, the macro issues, and then we'll do IVF if we have a micro issue, is sort of how it was explained to me at the clinic level, because we did have male factor. So I mean, that was super fascinating, but we've been, saying to women, like, it's okay to ask for this test. You could ask for this, you can advocate for yourself and say, hey, let's do DNA fragmentation. We're willing to pay for it up front, because we want to know if we're just wasting time and money right now doing IUIs when it's never going to work, because we have the defragmentation issue. So do you have any, I'm putting on the spot here, but do you have any stats on like how many male factor, like how many do you see, like 1 out of 10 that would be DNA fragmentation being the issue?
Yeah, the prevalence of the problem is roughly, I would say, 5-10% of couples who have this problems. I would say closer to 5 than 10. 10 is big. That's not that bad. But also there's a smear also. You got these couples that are super fine, others that are in the okay zone, and others that are so bad that you really don't want to mess with it.
Right. So there's a scale.
But
there's a scale of like defragmentation. And then my next question is, can it be like reverse? Like, can you fix your the fragmentation if that's the issue? Like, can it be improved with diet, exercise, whatever? Sorry, we're going off script.
Right. So I there are many things that you want to know even before asking this question. The first thing is that there's a reason why doctors have not been trusting this test so much. Okay. Right. One of the reasons is that the test was invented by a researcher in the 80s, and this guy was a lab rat. Okay. He knew about how to run an analysis in a lab. And I hate to say it, because I really do have the utmost respect for OBGYNs. I have OBGYNs in my family, and some of my friends are OBGYNs, and I love these guys to death. But the thing is that if you start to play in the lab as an OBGYN, you're not the best expert to do these type of things. You're not a lab rat, right? You're a physician. These are 2 different jobs. And sadly enough, in the past, I don't know how it really happened, but a lot of people running fertility clinics have been playing the game of trying to provide results with DNA fragmentation, and they didn't know what they were doing at all. And it's not just in Canada or in the US, it's across the map. I could cite you papers written by super serious scientists in the world, published in really well-respected journals, really serious scientific journals, saying, look, will you stop publishing freaking crap about this test? when researchers get that mad, most researchers are super agreeable people. They don't like to raise conflict,
Yeah,
right?
seriously.
So at some point, when people lose it to this level, it's because there's a lot of S has been done, and right now I have to say that you have to understand that all DNA fragmentation tests are not equivalent by any stretch of the imagination. It just doesn't make sense. Okay, you don't measure that by flow cytometry. You're done. I don't care how good your microscope is. I don't care how good your technique is. There's no way you can control the conditions by which you're going to measure DNA fragmentation if you're not using super sophisticated objective tools that measure it on thousands of cells at the same time. Okay?
Yeah.
Because variations are matters from sample to sample, and the level of quality control that you need to apply to have this done straight is high. So you need expertise and you need sophisticated equipment to do that. Lots of companies have been selling to fertility clinics ways of doing it more easily, blah, blah, blah. They lose it when they do it. I'm sorry, but that's what is happening. So doctors end up not trusting the test in the end. Well, guess what? Numbers don't mean anything anyway. So it's not super surprising that they've lost faith into this test. So that's why they've been hesitant over the past few decades to call for this test, because they're like, look, the test doesn't mean anything like 1 time out of 5. I mean, tell me about a doctor working in ER, okay, who would call for a test that is wrong 20% of the time. This test will the guy is going to run up in the biochemistry lab and tell the clinical chemist, look, stop doing this crap. We don't need it, right? Yeah. So that's a very important thing to understand. And there are tests that are done by cytometry that have no potential to become a clinical test either. So they're very good tests to run as an experimental protocol. They can have their usefulness in the research lab, but you can't standardize these tests to become a clinical test. And doctors still do it because they don't understand the subtlety behind it. So that's one thing. So make sure you deal with a lab that knows what it's doing when you need to find very good experts in flow cytometry to have this test done. That's the first point. The second point is, well, your question was more about if this test should be called earlier and versus later, and what it means exactly. Well, if you perform the test earlier, okay, at least you have a chance to know and decide and maybe improve your chances towards one or the other treatment. And what are the treatments available? Well, I've been super surprised because I didn't believe in that when I joined ranks in the fertility field. But actually, for a very good proportion of patients, vitamin supplements work. Okay, I was not a believer of that at all before. I've seen many patients taking very good vitamin supplements. And I've seen patients going from disastrous results back on track over the course of like 3 months. I was like, man, what's been happening to you? And the only thing that the guy has changed is just getting more sleep and getting his vitamins. And boom, he's back on track. So there's something you can do. But for God's sake, have this parameter tested earlier than later, because if you don't know, you might be pedaling in the swamp for months and months without even knowing what's happening. And so, just do it earlier.
Yeah, I think that's like fertility 101. Like the earlier, like we get out in front of these issues, I often hear in our community too, like there's so many people that go without a diagnosis with this unexplained infertility issue for so long. And there's almost like a relief when there comes a diagnosis, or like, okay, we found the problem. It's like this hidden treasure of why this hasn't been working for these perfectly healthy individuals or whatever. So testing early, awesome. I think that's such a good takeaway. What happens if the spermogram shows little or no sperm? Could you speak to some of the treatment options maybe that can happen in those cases? I know you're not a urologist, you're a biologist, but we'd love to hear a little bit about, maybe where folks who are in that seat today, or who are just found out maybe they have a diagnosis of azoospermia, like what's next for them?
Yeah, well, there's one thing you want to know just before we jump into this field. I was just listening to your comment after my answer, and what came to my mind is that you probably also want to know that there are other tests like DNA fragmentation that get skipped on, like measuring
Please.
like the presence of the antibodies against your own sperm cells, the ability of the sperm to undergo acrosome reaction, the ability of the sperm to undergo hyperactivation. All these things the sperm cells will have to do if you go in IUI, and if we can predict that they will fail at doing it, you have no business in IUI. And DNA fragmentation is one of the tests, but there are many others like that. So, it doesn't hurt to give us a call. Okay, we're not going to put pressure on anyone if just out of providing information. So better have a look at the type of information we're putting on the web. Worst case scenario, give us a phone call, and we're super generous people at trying to explain these things. So never hesitate if you have a question about what should I do from there. It's not a problem. Regarding azoospermia or cryptozoospermia, what happens is that there are many reasons why men could end up in a situation where there's where there's not a lot of sperm cells in the ejaculate. It goes from genetic syndromes to hormonal problems, to obstruction of the genitalia, to problems at the way the person ejaculates. There's so many causes that could lead to that it's hard to wrap up the informations. But let's say that the first step is just to make sure that concentration has been measured well. Okay, so I'm going back to what I told you earlier in the podcast, but one of the things that you want to make sure is that we know how many sperm cells you've been producing. So if you have an azoospermia diagnosis, what it means is that nobody could find spermatozoa during a routine analysis on the microscope. Sometimes labs will check in depth and they will try to, find them, but at some point they give up because they don't even know if they're looking for something that even exists, right? So in order for science to make sense, reality has to be understandable. So at some point, the poor embryologist goes like, how much time am I supposed to run for nothing? So it's super discouraging because they're super agreeable people. They're there, they're committed, they're passionate about their work, they want to help, and they're basically tattooed with empathy for the couple, but they always feel like they've been given up on the couple when they can't find spermatozoa there. The reason why I'm explaining that is there's a solution. You just ask the flow cytometer to check on these samples. And recently, we've shown on a very small cohort of people, I must admit, it's not a lot of patients, but we've seen in a small cohort of patients that 1/3 of the patient coming from a specific fertility clinics who we thought were azoospermic were actually not. Some of them, they had just produced a super bad sample the first time, so it's no big deal. The second sample was fairly good, and for them, it's not a big problem. So make sure you do more than one spermogram before you panic. That would be the first thing. The second thing is that some of these patients, we could find spermatozoa. They were so rare that chances that any fertility clinic could actually grab them and micro-inject them are like the chances that it would work is basically zero. So that's super discouraging. But at least, we can provide the right diagnostics to men. And you'd be surprised. Guys go like, well, at least I know I'm a man. You found spermatozoa there. And not saying that you need to produce spermatozoa in order to be a man, but it basically always brings some light in their eyes to have the right diagnostics. So that we like and we feel is useful. But for about 1/3 of those patients that were not azoospermic after all, there were just enough sperm cells that it could be planned that the clinic would use them for ICSI. And so they could have the chance to have their own biological children and without going to surgery, micro-TESE, or without using donor semen. Usually the fertility clinic will back themselves up with donor semen because let's say the spouse produces, 15, 18 eggs, and all they can catch is maybe 5 or 6 rare spermatozoa to micro-inject. well, they'll probably micro-inject the 6 best looking oocytes with the partner's semen, right? And then the remaining ones with donor semen, and then try to do a fresh transfer, freeze the rest, blah, blah, blah. But at least they have a chance to conceive their children. And we've seen couple conceiving their own biological child after first receiving a diagnostic of azoospermia. That's a lot of magic happening there, right? So the first thing is really to make sure that we have the right score with the sperm concentration. If hormonal treatments to stimulate sperm production is used, you might go from producing 0 to producing just a few thousands of sperm cells that are hard to identify on a microscope. So if you go through clomiphene or any sort of hormonal treatment to induce sperm production, you want to know as fast as possible that it's actually working and bringing you to a sperm production window that can solve the problem. I'm very afraid that sometimes they use hormonal treatments to induce sperm production on men, and that actually work, and they miss on it because their way of detecting sperm production is not sophisticated enough. How sad is that, right? If that happens, I've never seen it, but I suspect that these guys are out there for me to grab at one point. So the more we're going to be able to evaluate azoospermic or cryptozoospermic guys, the more the flow cytometer will have things to teach us. So I'm really looking forward to do more of that. It's just getting started, seriously, but yeah. So all these other things, all these means of treating these low-level sperm cells, these men who produce very low concentrations of sperm cells include hormonal stimulation. They can grab sperm cells from the epididymis, from testicular aspiration, called TESE. They can also try to do what they call micro-TESE. So it's basically a dissection of a testicle. So you can grab the seminiferous tubules inside the testicle where sperm cells are being produced, and they micro-dissect it in the lab, and they try to extract a couple of rare sperm cells to micro-inject from there. So it's you have to be an expert doing that. Urologists who do that are literally magicians. I have the utmost respect for them being able to pull this type of thing off. But before going there, make sure you're going there for the right reason, right? So we need to have this sperm sample tested the right way. So
now we've talked a lot about different outcomes and how sperm can be affected, but what should we be looking for? How do we know? Even before we get down the fertility journey, is there anything we should be looking for to help us identify that somebody might have this issue before they start trying for a year unsuccessfully?
Oh, you mean can somebody have symptoms that would indicate that he might be having sperm production problems? There are, I'm not a geneticist, and I wouldn't know all the syndromes by heart, but just to give you an example, there's probably, and I hope people won't be too mad at me if I don't have the numbers right, but if we talk about, let's say, a syndrome like Klinefelter, right? So these are men who are not XY, but they are XXY, okay? So these men, I think the frequency of Klinefelter is probably somewhere between 1 in 500 to 1 in 1,000. And they have distinctive traits. They're usually tall, and they can have gynecomastia, like the appearance of a little bit of breast on their chest, things like that, signs like so. And there are also syndromes that are pretty harsh. Like we know that some men have mutations in the receptor for the androgen hormones. I think the syndrome is called AI or ADR, something like that. Can't remember exactly. But if you have a mutation in the receptor that's supposed to catch testosterone and helps it do its job, you can imagine the impact. So these guys will have all sorts of more feminine expression in their traits. like lighter voice and more feminine traits in their face. So things like that exist. So in all doubts, the best thing is just to, consult the physician, your family doctor, ask questions, and don't hesitate to ask to be seen by an endocrinologist, right? If you have doubts about of this nature, I would say that the best person to talk to is not a guy like me, not necessarily either someone who's a reproductive doctor necessarily, although they know a lot about these things because they've seen a lot of these cases, but people in endocrinology specifically, and these guys are also, we have endocrinologists in fertility clinics in North America somewhere, in some fertility clinics. So the type of expert you want to consult is an endocrinologist. These guys know all about hormones and also the syndromes that can lead to abnormal hormone expression in the body or abnormal hormonal action in the body. So they would probably know. But yeah, I would guess, I know, the fertility doctors in Montreal are so great. I think that they would all know about these things right off the bat. So, yeah. But, lab rats like us, we're not super good at, knowing all these things. We're not physicians, as I said. So they're going to be so much better than us at dealing with these stuff.
Well, we're getting close to the end here.
Yes.
Yeah. Gosh, the hour always seems to fly by when we're on these.
It does.
But before we wrap up, we've got some rapid fire Q&As for you.
All right. Let's get it done.
Fast answers here. So when should someone get a sperm analysis done?
Sperm analysis done 6 months if one of you two is older than 35 years old, and 12 months without conception in other case scenario. Also, there are many other reasons you would want to have a spermogram done. We see couples who have, we call them the prenuptial spermogram. So some cultures, they have spermogram done before marriage. We see guys who are just worried because their brother or their father had problems conceiving. We see men who underwent they went through their cancer survivors. So there are many different cases. But typically, after 6 months without conception, if you're 35 years old and up, and 12 months if you're younger than that.
All right. Can lifestyle changes improve your sperm parameters?
Yes, but not to the extent that you need to overthink it, right? So what you do to take care of your testes is the same that you would do to take care of your heart, right? So 40 minutes of intense physical activity every day, if possible. But, even like 2-3 days, just getting out of the couch is the big factor, right? Get the engine running, push some weights, move things, go out for a run, go hike, do some sports so you can get good sleep. And you can have that interaction between cortisol, melatonin, testosterone, going the right way. So eat well, do your exercise, sleep well, and your job is done, basically. So not too much alcohol. Drink of wine will not kill you, will not sterilize you either. No drugs, no smoking, and your job is done. Because I see people all the time, ordering stuff everywhere and overthinking it and blah blah blah. The stuff that you need, that you are responsible for, is just having a good hygiene of life. That's it.
Mm-hmm. All right.
Great.
Last rapid question. What's the most common misconception about male fertility?
It has to be that people think that they don't have a fertility problem because their spermogram from the hospital or the fertility clinic is normal.
Right.
So that has to be the worst thing, because those parameters are important to check. If they're good, it's a good thing, but you can't stop there, right? It's the same thing as having a look at a man and saying, is he healthy? Well, I'm having a look at this guy. He's breathing. Well, it's good, right? He's standing. It's also very good. He can move from room to room. Very good. but is he having hypertension? Does he have a cholesterol problem? Is he hyperglycemic? We have to run some tests to check that. So spermogram is just investigation on the surface. So don't stop there.
Yeah. Oh, that's great advice. I love that. Dr. Matt, thank you so much for joining us today.
Sure.
Honestly, every time we chat, I have a million more questions that I could ask, and I'm sure I will hit you with them next time I see you at a conference or wherever we are. And it's so incredibly informative and an amazing way to kick off this month, talking about male factor. Can you just tell people where they can go to learn more or book a spermogram with Nasci Biomed?
Yeah, so don't hesitate to reach out to us. It's super easy. Phone number is 514-316-1518. You can phone the lab. We're super responsive. You leave a message, worst case scenario, and we're going to be there. Also, you can find us everywhere at NasciBiomed.com, YouTube, Facebook, Instagram, at NasciBiomed, and that's it.
You have a lot of followers on YouTube and some really big videos. So definitely, friends,
Yeah,
we're going to link everything in the show notes.
Yeah, the azoospermia is like 65,000 views, and I was like, and it's not even a good video. So people are interested. So reach out whenever you want. No worries.
All right. So everyone, don't forget, we're only a few weeks away from our amazing fertility party fundraiser, and tickets are still selling fast. So make sure you grab your ticket before they all sell out.
Yes.
Thank you, everyone, for joining us here at Fertility Village Live.
We'll be back next week. We have a male fertility coach joining us. It's going to be an exciting episode, June 11th, 8 p.m., streaming on all platforms. We are going to get Instagram back up and running next week. So sorry about that, everybody, for this week. Hopefully you found us over on Facebook or YouTube today. I know Tiffany was linking it on Instagram to come over to YouTube if you were there trying to find us tonight. But this episode will also be available on Spotify after this, anywhere you get your podcasts. The Oasis Fertility Podcast is what you're looking for if you're looking for this episode later down the road. So share it with your friends. If you know somebody struggling through this diagnosis or not sure where they fit in with the diagnosis, share this episode with somebody. We would love you to do that. And don't forget to like, follow, subscribe, all the things. I don't have anything anywhere, but I'm going to point anyways. Okay. Thanks for joining us again, Dr. Matt. We love you. And thank you for joining Fertility Village Live tonight. Remember that wherever you are today for tuning in, you're not alone. Welcome to the village, and we will see you all next time.
Thank you.
Thank you.